Okay, so in the last video in this deep learning with Pytorch series, we talked about the transfer learning concept, and also we have seen like how using a pre-trained model, we don't have to like bother about what would be the size of the kernel, how many kernels should we implement, so we can take help of other previously used architecture. And with those architecture, we will kind of customize those architecture according to our use case, and based on that we can do any computer vision task, right? So first of all, like a few of the inputs. So I'm running this in Kaggle notebook, so I will also share the link of this notebook in the description of this video. So if you see like the data set which we are using, if you just go to the node input data tab, so we have two folders, the train and test. So if I go inside the train, so there are 5 folders. So there are 5 classes of flowers which are present in the train set, and also similarly we will have 5 classes of images in the test set also. So these are the name of the classes or the type of flowers which we have, and then we also have the test set, right? Now let's go back to the notebook and let's see. So these are like few of the transform or few of the transformations that we are doing, the image augmentation along with the normalization of the images. And this is the data directory which I have given as a path for data underscore dir, right? So we will also see like how to load the images from a particular folder. Those folder are like train and test, and then build the data loader on top of those folders, right? So using this method like datasets.image folder, you can mention the train and test folder along with the transformations for train transform and test transform, and we can load our data set, right, from particular folders. And if I just do this like image datasets train.classes, we will see 5 classes are present, and we can also get back the class to index using this. So for each of the classes which has been read from the folders that are present in those particular train and test, right? And we will get corresponding indexes out of those class name, because we only need to pass the index while doing the training the model, right? So once we prepare the data set, then what we will do is we will create the train loader and test loader with a batch size of 10, and so we will also mention that shuffle is equals to true, and with that we can check, we can pick up any of the train loader batch, and we can check the shape. So as I mentioned, like the batch size is 10 and it's a color images, so like there are 3 channels and the height and width are 224 cross 224, right? And also the labels are nothing but the indexes of those particular folder. So the model which we will use the VGG16 model, that is a pre-trained model. And so as we are using the Kaggle kernel, you need to keep the internet settings on so that the weights would be downloaded from the internet and will be stored in this particular notebook. Then what we will do is we will freeze the model layers. So we will freeze all the layers in the network except the final layer, right? So the requires grad equals to false will freeze the parameters so that the gradients are not computed in the when we call the dot backward method, right? So the weights of this layers, particular layers, where we have mentioned requires grad equals to false, that will be filtered out, right? So with that we have this model, and after that what we will do is we will like extract the feature from the classifier, the input features, which is like 25088, and after that using that number of inputs as a column, as a feature. So if you see, this number of inputs is 25088, and we will add back certain linear layers, the fully connected layers, right? So this is the number of inputs which is coming from the model. So this is coming from the model, right, from the VGG16. and we get the 5 as an output. 5 as the last layer's number of nodes, because we have 5 classes, right? And with that we will also add this log softmax. So as we are doing the multi-class classification, so we will add back that thing, right? So now if you see, we have the last layer added here. So this is like the classifier is being added here, and we have one fully connected layer with the input features and output features. Also we have the log softmax with that. So now what we will do is we will check if CUDA is available or not, and based on that we will create a variable which is train on GPU, and we create our loss function which is negative log likelihood loss, then the optimizer, and these are like normal training process where we are training the model for 10 epochs, and we will calculate the loss and also the accuracy for each of the epochs, right? And once we have that, we can also check on the test set what is the accuracy of the model, that is 79%, right? So this is what I wanted to show you, like how you can use a pre-trained model. You can freeze certain layers of those pre-trained model, and then add back a classifier on top of those pre-trained weights, and then you can train your model. Yeah, so that's the thing. So the accuracy is currently like 79.3. So you can also improve the accuracy by training the model for larger number of epochs, and also using a different model architecture or the classifier which we added. So if you add more layers to that, that can enhance the model performance. Okay, yeah, so that's all I wanted to discuss in this video. Thank you. Thanks for your time.